Hello, this is a video of solving the A Levels P1 2022 exam series. Right, let's just begin. The first question, right, says solve the equation 3x plus 2 equals to 2 divided by x minus 1. Right, so by looking at this equation, so you have a linear with a fraction. So what we can do is we can just cross multiply. Can multiply x minus 1 to the left side of the equation, and that gives us sort of a quadratic equation. So from here you should be familiar with solving quadratic equations. So very quickly we can actually expand this. So that would be 3x squared minus 3x plus 2x minus 2 equals 2, and that's what we have. Minus 4 equals to 0. So at this stage, let's check if this can be factorized. Yes, it can be. You can either do a cross multiplication factorization, or if you're fast enough, you can just basically factorize it from here. X to -1, so -4 and plus 1 here. Alright, so after you factorize, the rest is just solving. X equals to 4 over 3 or -1. So these are the answers. Now before you move on to the next question, always check that this satisfies the equation, because this essentially is a fraction. Right, we have used quadratic methods to solve this equation, but the original equation is the form of a fraction, a rational fraction with a linear equation. So we have to check that the answers that we obtain satisfy the original equation, and yes, it does. When we have -1, it's permissible in the denominator, and 4 over 3 is permissible in the denominator. Alright, so these are the answers. Next, moving on to question 2. Question 2 says that you have the equation of a curve such that dy dx, this is given in the question, 12 x minus 1 to the power of -4. And it's given that the curve passes through the point P is given as 6 and 4. So find the equation of the tangent to the curve at P, that's part A. So to find the equation of a tangent to the curve, the first thing to do is know that the tangent is a linear tangent and has the equation mx plus c. So we need to find the gradient of the tangent by using dy dx, alright, at point P. So at point P, so this is what you can do at point P. 6, 4, you can substitute 6 into the dy dx, which gives you the m, which is 12 1/2 6 minus 1 to the power of -4. So that's 12, 3 minus 1, which is 2 to the power of -4. So this would be 1 over 16, and that gives us the answer 12 over 16, which is 3/4. So that's gradient. Alright, so there are two ways, or many ways, there are three ways, alright, to find the equation of a straight line with m. The fastest way, given the point here, is to use this formula, which is y minus 6 equals to the gradient multiplied by y minus 4 here, x minus 6, y coordinate is 4, x coordinate is 6. So from here we can find the equation, multiplying everything out, 3/4 x minus that's 18 over 4 plus 4, and eventually the equation is just 3/4 x. That gives -½ Alright, -18 over 4 plus 4 is -½ So that's the equation of the tangent. Right, that's the answer for first part A. Right, moving on, B, find the equation of the curve. So we are given dy dx, we have to find the equation of curve, which is y. So therefore for part B, alright, we basically have to integrate this expression. So let's just integrate this. 12 negative 4 dx. So here 12 is constant, we can take it out, we can leave it outside and integrate basically this thing here, which is first of all, there's a linear and that's a power negative 4. Integration, you up the power by 1, so that's just half x minus 1 negative 3 divided by a new power, not forgetting there's half x in there, so you have to divide half plus c. Okay, so that's the integration. Alright, so now simplifying this, we would have that would be negative 8 half x minus 1 to the power of negative 3 plus c. So that's y. Alright, so that's the equation of the curve. So the last step is to solve for y. Going back to the question, you're given a point P, which is 6, 4. So we can use this point to find C. Alright, where y is 4, x is 6. So half times of 6 minus 1 to the power of negative 3 plus C. So solving this, 3 minus 1 is 2, so that's minus 8 over 8 plus C. Therefore, C is 5. Alright, so you can solve this using your calculator, not a problem. And then once we've found C, we can eventually write down the equation of the curve, which is y equals to negative 8, 1 half x minus 1 to the power of negative 3 plus C, or you can write it in a fraction form, negative 8 half x minus 1 to the power of 3 plus 5. Both are acceptable. Right, so that's question 2. Moving on to question 3 quickly. Right. Okay, so that's question 3. Right, it says the curve has the equation, and that's given y equals to ax to the power of half subtract 2x, where x is greater than 0. Alright, and a is a constant. The curve has a stationary point at P and has x coordinate 9. So you have P given and you have 9, and we don't know what the y coordinate is, which is exactly what the question is asking. Find the y coordinate of P. Alright, so this is actually a stationary point. So stationary. In other words, what do you understand by stationary point? Stationary point, you can deduce that at the stationary point, dy dx is 0. Maybe if you're not sure, you can draw a rough curve. Then that's a stationary point. It could be a maximum or minimum. We don't really know, but we don't really care at this in this question. Just need to know that a turning point, a stationary point is a turning point, and the dy dx at the turning point is 0. Okay, this is what we can infer. So what we have to do is we differentiate this and equate it to 0. So that's the strategy. So we start differentiating. Dy dx equals to half ax negative half minus 2. And this must be 0 at this point where x is 9. So what we can do is we can substitute 9 at P. Alright, so half a 9 to the power of negative half subtract 2 must be equals to 0. Alright, so solving this would be 1/3 using a calculator, or you can just simply solve 1 over 9 and square root 9 will be 1/3. So 16a subtract 2 is 0, therefore a is 12. Okay, so once we have found a, we can solve for y. Alright, we place it back into the equation and we solve for y. Y is just 12 times 9 to the power of half minus 2 times 9. That gives us 36 minus 18, and that's just 18. So that's the y coordinate of P. Done. Right, moving on, that's question 3. And now let's look at question 4. So question 4 says that the coefficient of x squared in the expansion this is given in the question 2 over p x to the power of 5 plus 1 plus px to the power of 6 is 70. So find the possible values of the constant p. So first of all, inspect the problem. You have 1 and you have 2 over px to the power of 5, and you have 1 here. So we can safely draw out the x term by using the formula. The formula is you need a square here, which is power 2. So therefore we use 5c2, 2 over px square. Alright, so that's the x squared term. Similarly for this one, we can use 6c2 px square. Alright, so that gives you the x squared term, and the coefficient of these two terms added together is 70. So I can just equate this to 70x squared. Alright, mathematically. So expanding this, 5c2 is 10. And squaring in, you get 4 over p squared. I can drop the x squares now because I can just focus on the coefficients. Alright, and 6c2 I believe is 15 and p squared, and that gives you 70. Alright, so this looks like a quartic. When we try to solve this problem, first of all we try not to work with fractions. That's a denominator here. We can just multiply p squared across. That will give you 40, 15p4 and 70p squared by multiplying p squared away. So this looks slightly bearable, and you can see that this is actually a power 4 and it looks like a quadratic with a power 4. Okay, you can just see p squared as substitute, say a. Alright, so moving everything to one side like you would have done in a quadratic. Plus 40 equals 0, and we can simplify this a little with by looking at the numbers that are multiples of 5. So you can just divide 5 across. So this will be 3 p4. Divide 5 would be 35 p2 and 8. Sorry, divide 5. So 70 divided 5 is not 35. 70 divided 5 is divide 5 is 14p. Alright, so that's 14p squared. Alright, so thinking ahead, can this be factorized? I think 12 plus 2 is 14, yeah. This is factorizable. So this will be 3p4 minus 2, and sorry, 3p2 and p2 minus 4 equals 0. Alright, p2 not p4. Okay, where p2 is a substitute. Right, if you let p2 be a substitute of a, for example. Alright, factorizing, you get this, and therefore we have 4 answers. So we will have plus minus square root of 2/3, or plus minus square root of 4, which is 2. So these are the answers for question 4. Right, find the possible values of constant p. So there are 4 answers. Alright, and so that's question 4. So moving on to question 5, 5a. Right, the question here says you are given a diagram of a sector OAB with a circle with center O. The length of the arc AB is 8. So briefly drawing the diagram. That's what it is. This is a shaded part, and that's O. This is 8 centimeters, and that's A, and that's B. So that's given. And it says that the perimeter is 20 centimeters. So, well, the perimeter is 20 centimeters. So we can find the radius first without even looking at the question. Or we can just go ahead and find the radius, which is OA and OB. So OA is the same as OB, which is the radius, which is 20 minus 8 divided 2, that's 12 divided 2, which is 6 centimeters. That's a radius. Right. Then the question says, find the perimeter of the shaded segment. Well, the perimeter, so sorry about this. Right, the perimeter is basically 8 plus the length AB. Alright, 8 plus the length of AB. So we need to find AB, and that's 6 centimeters, which is the radius. So we can use the formula R theta. R theta equals to 8. That gives you the arc length. Alright, we can find theta first. R is 6, so theta is 8 over 6, which is 4 over 3, 4/3. So with theta, we can actually use cosine rule to find AB. Alright, we have two sides with an enclosing angle, so therefore AB essentially is just square root of 6 squared plus 6 squared minus 2 times of 6 cosine 4 over 3. Now remember, this 4/3 is in radians, so you need to change the mode on the calculator to radians. And having done that, alright, I'm not going to solve this because eventually the perimeter can be solved together with this. Alright, so that I get a more accurate answer. So it's basically 8 plus AB. Alright, so that's roughly using the calculator. Right, I can just type the string of numbers, 6 squared plus 6 squared. Alright, so that's done here, and the perimeter is about 15.4. So this is about 15.4 centimeters. Alright, so that saves some time if you actually add everything together in one line on a calculator, rather than trying to evaluate this and approximate this to 3/4 significant figures. So just have to be very careful about the accuracy if you have done this on the calculator before adding the 8. But it shouldn't be a problem because this is a whole number, so when you add to that, you will still have the same 3 significant figures, roughly. Alright, so that's A. Moving on to part B, as expected, find the area of the shaded segment. Alright, so to find the area of the shaded segment, so essentially is the area of the sector, subtract the area of the triangle. Alright, we can draw this again. 0.86 centimeters. Alright, this is 4/3. Okay, so this is question 5. Alright, area of the shaded region. Is essentially area of the sector. We can use the formula half r squared theta, subtract the area of the triangle, half r squared sine theta. Alright, so we can just put everything in since we have all the values. 6 squared, this is 4/3, subtract 1/2. Again, it's good to just type everything in the calculator to prevent any accuracy loss. So if you've done that, this will be approximately 6.51. in 3 significant figures, centimeter square. Okay, so that's question 5. Moving on to question 6. Alright, it says show that the equation may be expressed in the form a sine square theta plus b sine theta plus c. So maybe let me just write down the equation given in the question. Sine theta plus cosine theta plus 1 divided by sine theta subtract cosine theta equals 1. And this may be expressed as in the form a sine square x theta plus b sine theta plus c equals 0. Alright, so that's the objective, and that's where you have. Alright, so what we can do is to simplify this to the state. To do that, first of all, we observe that there are 2 fractions here. So the easiest strategy to think about would be to combine these 2 fractions first and see what happens. So to combine the 2 fractions, the denominators must be the same. So obviously you will cross multiply in the sense. You have sine theta subtract cosine theta on this side, and you will have sine theta plus cosine theta on this side with a common denominator, sine theta plus cosine theta, sine theta subtract cosine theta equals 1. Alright, from here you can see that cosine theta can be crossed out. We have 2 sine theta here. So sine theta plus sine theta, it gives us 2 sine theta. And denominator as a fraction can be brought across. Alright, and this is sine plus cos, sine minus cos. So we end up with sine square minus cos square. Difference of 2 square formula. Alright, so almost there. We look at what we need to have. That's what the answer should be. And it's in sine and sine square. So we have sine and sine square. The problem is cosine square. We need to convert this to something in terms of sine. So as we know in trigonometry, we can change cosine to sine by using this identity. Cosine square is 1 minus sine square. So everything now is in terms of sine. Alright, simplifying this, let's just do it quickly. This will be sine square, subtract 1 plus sine square. Okay, and moving this across, alright, we arrive at this answer, 2 sine square theta minus 2 sine theta minus 1 equals to 0. Okay, so that's it. This is part A. Alright, expressing the fraction in the form of a quadratic. And hence solve this for theta between 0 to 360 degrees. So this is in degrees. We have to convert back to degrees on our calculator to solve the answer in degrees, since question given to you is in degrees. So again, this is in a quadratic form with sine theta as the substitute. So we can solve this, but I don't see how this can be factorized, so we have to go ahead by using the formula, quadratic formula. So minus b, which is 2, plus minus b squared, which is 4, minus 4ac. So maybe just write this out. Okay, divided by 2a. Alright, so let's simplify this a little further. Alright, so this gives us 2 plus minus square root. This will be 8, 12, root 12 divided 2 times 2, which is 4. So this can be further simplified as 1. This is 4 times 3, which is 12, so which I can take out root 4, which is 2, and this is root 3 divided 2. Alright, there's no need for you to go to this extent. If you don't want to, that's fine, you can use calculator, since eventually we have to use calculator to solve for theta. Alright, but here we can see that there are two values. Sine theta is either 1 plus root 3 over 2 or 1 minus root 3 over 2. Alright, so we can see that this is not applicable, because 1 plus root 3 divided 2 is definitely more than 1, which sine theta cannot be more than 1. Alright, you can verify by using a calculator. 1 plus root 3 divided 2 is more than 1. Alright, so this is not applicable, which we reject. And what about this, which is about negative 0.366 in value. So question given to you is such that the range must be between 0 and 360. Sine theta gives you a negative ratio. So in other words, this would mean that the answers will be in quadrant 3 and quadrant 4. Alright, so to do that, we have to sine inverse the negative of this, which makes it a positive. So what we can do is we can sine inverse that first. So the basic angle or the principal angle, alright, is what we call it. Alright, or rather we find the acute angle first by taking away the negative. Alright, by taking away the negative, which means that I can do sine inverse of this with the negative. Sine inverse with negative of this. So that's about 21.47 degrees. Okay, the basic angle is about 21.47 degrees. So to find the answers for theta that will be in the third quadrant, we just add 180. For quadrant 3 and for quadrant 4, we subtract from 360. Alright, so I keep it in 2 decimal places because the standard format for the exam is 1 decimal place for degrees. So I can round it up later on. Alright, so I'll just add to 180, that's 201.5 degree. Similarly, that's 338.5 degree. Okay, so these are the answers to part B. Alright, so that's question 6. Quickly moving on to question 7. Question 7 goes like this. So you have a tool for putting fence post into the ground. It's called post rammer. The distance in millimeters that the post strikes into the ground on each impact of the post rammer follow a geometric progression. So it says geometric progression, which is sequence series problem. The first 3 impacts cause the post to sink to the ground by 50 millimeters, followed by 40 millimeters, followed by 32 millimeters respectively. Part A, verify that the 9th impact is the first in which the post sinks less than 10 millimeters into the ground. The 9th impact. So this is a geometric progression, GP. And since these are the first 3 terms in the GP, we can find a ratio, which is U2 divided by U1, which is 4/5.8. We can verify this ratio is consistent throughout by looking at the next 2 terms, which you divide by 8, you get 4/5, which is consistent. Alright, so once we have the ratio with the first term, we can actually look at the 8th term. Alright, because the question actually asks about verifying the 9th impact is the first impact that sinks the post in less than 10 millimeters. So this must be more than 10 millimeters. Alright, so let's just figure this out. So U8 is essentially a r to the power of 7 n minus 1. Alright, solving this, 50.8 to the power of 7 that's exactly 10.48576. That's more than 10. So U9 would just be 0.8 to the power of 8, and that gives us 8.3888608. So that's the first time that it falls below 10. Alright, so you're supposed to verify it, and that's verified. Alright, you've done U8, you've done U9, you show that the 8th impact is more than 10, and the 9th impact is the first time that it reaches less than 10. Next, find to the nearest millimeter the total depth of the post into the ground after 20 impacts. So basically you're adding up all the impacts, alright, for the first 20 impacts. So B would eventually just be sum 20, and using the sum formula, we have A, we have R, so the sum formula is basically 50 1 minus 0.8 to the power of 20, 1 minus 0.8. Okay, solving this quickly, 51 subtract 0.8 to the power of 20 divided by 1 minus 0.8, that's 247, so roughly 247.12. And the question says find to the nearest millimeter, so that's the nearest millimeter, so that's the answer. Alright, for B. And part C, find the greatest total depth in the ground which could theoretically be achieved. So basically this question is asking about sum to infinity, right? Because what's the greatest depth? So if you actually add up all the depths, that this is going to be bounded, and r is less than 1, so yes, we can safely say that there is a sum to infinity because r is less than 1 and the depth is getting smaller and smaller. So therefore sum to infinity, essentially using the formula a1 minus 0.8, which is 0.2, that's 500 over 2, which is 250. Alright, that's just the sum to infinity. Done. Question 7. Moving on to question 8. Alright, question 8. You're given a function. The function is defined by fx equals to 2 minus 3 divided by 4x minus p. Okay, you have a rational function here where x is greater than p divided by 4. Okay, so that's the question given, where p is constant. Find f prime x. So f prime x, look carefully, that's f prime, which in other words that's the differentiation of the function fx, and hence determine whether f is an increasing, decreasing, or neither. So we can differentiate this. So to differentiate this, maybe let me just slow down how we get that. Alright, so we can actually change the function to this form before we differentiate it. Alright, so once we have the index form, we can start differentiating. So differentiate the constant at 0, differentiate this expression, you bring -1 down, you have 4x minus p, subtract 1, which is -2, and you do a chain rule here, multiplying 4, the differentiation of what's inside. Alright, so putting this together, you can see that this is positive 3 times 4, which is 12. That's power -2. We can put it in the denominator, and that's the differentiation of fx. Now, the question obviously went on to ask you to determine whether this is an increasing or decreasing or neither function. We have to look at f prime. For decreasing, f prime is negative. For increasing, f prime is positive. By looking at this, for all x values, the denominator is always positive. So we can just say that. So 4x minus p squared is always greater than 0. So obviously, 12 divided by a positive number will always be greater than 0. Okay, so that's how you reason it out. So therefore, f prime x is greater than 0, hence fx is an increasing function. Alright, so that's part A. Moving on, part B. Express f inverse. Alright, so you have to read the question really carefully. This is inverse now. In the form p over a subtract b divided by cx minus d, where a, b, c, d are integers. Right, so we're supposed to find the inverse, so let's go through this. Alright, inverse. Step 1, you let y be the expression. Okay, so for some methods you interchange x and y, which I don't really encourage here because you get confused when there's a domain restriction. But in this situation there's no domain restriction, it's fine. Alright, if you do that method by interchanging y and x first. Right, well, I'm used to just making x a subject, so I'll just proceed with that. So so this would be 3 divided by 4x minus p, 2 minus y. To make x a subject, I have to interchange the denominator with this, so that will be 4x minus p, 3 divided by 2 minus y. Right, you interchange the denominator with this, okay, to draw out the x, and moving p across, so that will be 4x equals to p plus 3 over 2 minus y, and to dividing 4, x will just be p over 4 plus 3 divided 4 will be 8 minus 4y. Looking at the answer, there's a negative here and this is positive, so what I would do is I would draw out the negative from the denominator, draw out the negative, and that becomes 4y subtract 8. This fits exactly what the question is asking, so therefore I can write down the answer. F inverse is p over 4 subtract 3, 4x minus 8, where a is 4, b is 3, c is 4, d is 8. Alright, that's the answer for B. Moving on to the last part, C. Hence state the value of p for which f inverse is equivalent to fx. So that's what the question is saying. F inverse is equivalent to fx. So this question is interestingly phrased because it used equivalent instead of equal. So generally when we were asked to solve an equation where inverse equals to its function, we normally equate the inverse to its original function, which is this. Alright, that's the inverse, that's the original function. Normally we equate them together to solve for x. Alright, but in this case it's not solving for x, it's actually solving for p. state the value of p, and the question says state, so it's just 1 mark. In that sense, you're not supposed to solve, alright, because it's just 1 mark. So let's see what happens if we equate them together. So this is p over 4, subtract 3, 4x minus 8. We just use the equivalent sign, and this 2 here, 4x minus p. So it's interesting to observe that these two fractions are pretty much similar. Alright, and here you're supposed to use your observational skills, right, to observe that p could be 8. Alright, p could be 8 because these two are equal. Alright, these two are exactly the same, such that this is 8 and there's p here. Alright, but you have to confirm it with this one as well. If p is 8, this will be 2, which is equivalent to this 2 here. So therefore you conclude that p is 8. Alright, so there's no working here to be done, basically just using observation based on what you have obtained here. So that's the last part, which is worth the mark. Okay, next, moving on, question 9. Again, it's on functions. You're given two functions, fx and gx. Let's just start with fx first because part A asks for fx. So fx is given as x squared subtract 4x plus 9. Right, you're supposed to express fx in the form completed square form like this. Okay, so there are many ways to go about completing the square, especially this is a monic quadratic equation. So generally the approach I would take would be to break this into what we call a completed square form. A completed square form in this way is usually a squared minus 2ab plus b squared. Alright, I'll try to express it in this form so that I can complete a square. So looking at this, alright, I can actually break it up into 2x. 4 is 2 times 2, so I have a 2 as my b. Alright, I need 2ab, so 4 I break it up into 2 times 2, which I can have a 2 right here. A is x and b is actually 2. From here you can see that I need a 4 behind, which is 2 squared, which is 4, and the 4 can be derived from 9, which means I have 5 left. Alright, from here I can simply write down my completed square form, plus 5, that's it. Alright, so this is one way of solving. Now, if completing the square is something that is alien to you, what you can do is you can also expand this. Alright, so another method will be just to expand this and make comparisons. So this will be x squared minus 2ax plus a squared plus b. And you compare this with this. Alright, you can just make comparison by expanding this instead of factorizing. I would use factorizing, like completing the square. Instead of completing the square, you could just expand this and make comparison. And by looking at that, a is 4. Sorry, a is 2, because 2a is 4. You can do that. So by comparing 2a is 4, you can say that a is 2. That's how the 2 comes about. And with a found, you can find b. A squared plus b is 9, so therefore a squared plus b is 9. That's how the b comes about, which is 5. Alright, and with a and b found, you can put it back, and that's your answer. Alright, so yeah, that's just another method for you to think about if that's something that is more palatable to you. Alright, so that's A. Moving on to B. B is supposed to express gx in the same form. Okay, so moving on to B. So let's pick B. Right, and this is question 9b. So you're given gx as this. Okay, and you're supposed to express gx in the form of 2x plus c squared plus d. Alright, so that's what you're supposed to express. So similarly, it's a completed square form. Again, you could expand this and make comparison, or I would just use a traditional way of completing the square. So from here I can factorize 2 out, and I can see that this is a squared plus 2ab would be just 1. So I can break 6 up into 1 plus 5, and that's a completed square, which is 2x plus 1 square plus 5. Done. Alright, so that's B. Moving on to C, express gx in the form of fx. So you're supposed to express gx in the form kfx plus h. Okay, where k and h are integers that are to be found. So comparing this with fx was previously x minus 2 square plus 5. So how do we get from here to here? So first thing to do, we can ignore the 2 since 2 is outside. So we can just leave that alone. So you can see how can we transform x minus 2 to x plus 1. Essentially, you substitute x plus 3 to give 1. That gives you x plus 3 minus 2. And that's just x plus 1. Okay, and finally multiply 2 here. Alright, 2. You get gx, 2 times of x plus 1 squared plus 5, which is gx. Okay, so therefore the answer essentially is 2 times fx plus 3, where k is 2, h is 3. Alright, moving on to the last question, last part of this question, D. That's D. Alright, D, it says describe fully the two transformations have been combined to transform fx to gx. Alright, so from here we can identify two transformations. One is translation in the x direction, 2 is scaling of factor 2 in the y direction. So we just need to write down translation using a column vector, negative 3, 0. Alright, so be very careful when you have translation in the x direction, the signs are different. So plus 3, translation in the negative direction. Alright, and scaling, actually it's a stretch, but I will just use the standard word scale of factor 2 and along the y-axis. Okay, so that's question 9. Next, the last second question, question 10. You're given two graphs, and the two graphs intersect at 2 points A and B. A is 0, 1, B is 4, 5. Shown in the diagram, find the area of the region between the two curves. Alright, so I shall not attempt to draw the curves here, otherwise it looks really messy. So, oh well, maybe I'll just roughly sketch it so that you understand what I'm saying. So you have the curve right here, that's one curve, and that's another one that goes like this, with two tangents crossing at this point. This is point B, right, and that's alpha actually. Alpha between the tangents. Alright, and B has a point 4, 5, and A has a point of coordinate 0, 1. So the upper curve has the equation y equals to 2x half plus 1. The lower curve has the equation y equals to half x squared subtract x plus 1, x and y here. So part A, find the area between the two curves. So to find the area between the two curves, we always take the integration of the upper curve, subtract the integration of the lower curve, because when you integrate the upper curve, you're finding the area below the entire part of the upper curve, and if you subtract the lower part, you get what's in between. Alright, so therefore that's a strategy. So therefore the area is between 0 to 4. The upper curve, which is this, subtract the lower curve, dx. Alright, so let's simplify what's inside. So this becomes integration from 0 to 4, 2x half plus 1 subtract 1 minus half x squared plus x dx. So we can integrate this one term at a time. So this will increase by 1, which is 3 over 2. X 3 over 2 divided by 3 over 2. Increase by 1 half. X to the power 3 divided 3. And x squared over 2. Alright, at this stage you can use a calculator. And solving this, I suppose you get 8. Alright, so this is, well, you can solve this manually. So that's 4 over 3, x to the power 3 over 2. This will be 1, 6, x to the power 3, and x squared over 2, 4, 0. So 0 can be omitted because we have x terms in the entire expression here, so it will be subtract 0. So what we need to do is include 4. So we substitute 4 into this part. That will be 8. So this will be 32 divided 3 minus this would be 64 divided 6 minus plus 4 square is 16 divided 2, which is 8. So these two cancel out, so that will be 8 units squared. Alright, so that's the area. Now find the acute angle between the two tangents at B by, well, the acute angle is given as alpha. Alright, so find alpha. Alright, so that's part B. Now, to find alpha, to find the angle, we can find the tangents at the point B first. Alright, we can differentiate the curves at this point B and find the tangents. Alright, the strategy is to use the tangents. Since question given to you is involving tangents, so we can just find the gradients of tangents first. So first of all, we differentiate this one on the left, the one that is above. So dy dx essentially is just 2 half x minus half. Sorry, the minus half goes with x. Alright, and one's gone, and this gives us x to the power of negative half. So we can find the gradient of the tangent along this curve at this point B. So at B, let's just call this gradient 1, m1, or m1, which is 4 to the power of negative half, which is 1 half. Alright, and then similarly, dy dx, the gradient for the lower curve essentially is just x, I'll bring 2 down, minus 1. So similarly at B, m2 is 4 minus 1, which is 3. So we have the gradients of these two lines. Just focus on the two lines like this. Alright, this is M1. Alright, and this is M2. Alright, so this has a lower gradient, which is half, and this has a higher gradient, which is 3. The angle is in between, alpha. Okay, so to find the angle alpha, what we can do is we can use a strategy of using gradients with the horizontal, like this. Alright, we can use the strategy of finding the angle made with the horizontal. So M2 is this angle, M1 is this angle, so the difference is the angle in between. Right, because let's just say that this is x-axis, because this is alpha, opposite angles. So these two angles add up to this angle. So therefore the angle at here, M2, subtract the angle at M1 gives you alpha. Alright, so with that we can say that let's just call the angle here M2 be B, small little b, and angle with M1 as A. Alright, we know that alpha is B minus A. Alright, B minus A, because alpha plus A equals to B. So with that, we can actually find tangent alpha, which is tangent B minus A, which is using compound angle formula, tangent B plus tangent A divided by 1 minus tangent B tangent A. Okay, and why do we do that? It's because the tangent B and tangent A are basically the gradients, because tangent A is this and tangent B is the gradient. Alright, so that's the reason why I'm using gradients. Okay, so with that I can substitute the values into the equation. Tangent B is 3 half 1 minus 3 times 1 half. So that would be 3 and a half, which is 7 over 2. One minus 1 and a half, which is wait a minute. Right, I realized that I've made a mistake. This is minus, so this will be minus, and this will be plus. This will be minus, and this will be plus. So yeah. So 3 minus half is 2 and a half, which is 5 over 2. 1 plus 3 and a half is 2 and a half, 5 over 2. So that's essentially 1. So tangent alpha equals to 1 implies that alpha is 45 degrees. Alright, so that's B, and that's the last second question. Let's moving on to the last question, question 11. Alright, which is a circle, question on circle. Right. Okay, question 11. You have a circle with two tangents at C and B that passes through the point A on the y-axis. So maybe I'll just roughly draw the circle. Alright, you have a circle and it touches B and C at 10. This is A, and that's C, and that's B. That's D. Alright, so the circle has an equation x squared plus y squared equals to 20. Alright, so you're given that there are two tangents that passes through point A, tangents to the circle at B and C. So part A, it says by letting the equation of the tangent be mx plus 10. Alright, find the two possible values of m. Alright, so before we begin to solve the problem, we must understand that what's the meaning of tangent. Tangent, it means it touches the curve, the circle once. Right, so this m could have two values, one's a positive at B and one's negative at C. Alright, that's the reason why the question asks for two possible values of m. Now, since these 2 points on a circle, a regular circle with center 0, touches the point A, so obviously AB has the same length as AC. So therefore they share a common y value. Alright, so they have the same length. These are two congruent triangles right here. Okay, so it means to say there's just one y value. So what we can do is we can solve for y here. Alright, we can solve for y, and y has just one value. So what we can do is, since the question is given as this, alright, and the question sort of guide you by saying that use y equals to mx plus 10, so we can actually basically substitute this into here. Alright, it makes a little more sense by substituting the x value into here and solve for y, because there's just one y value. Okay, so what we can do is we can just make y the x the subject here, and alright, and therefore is x squared. Divide m and square both sides. Alright, so I can substitute this into here and we can solve for y. So in this situation, I will have y minus 10 divided by m squared plus y squared equals to 20. This becomes a quadratic expression. You can expand this out and we'll think about how to solve for m later on. Right, so we can just expand this, and that will give y squared minus 20y plus 100 divided by m squared plus y squared. Alright, we don't like to work with fractions again. I can just multiply m squared across, so this will be y squared minus 20y plus 100 my squared and 20m squared. Okay, so this is a quadratic. We can just put everything together on one side. So that's the A, and that's the B, and that's the C. Okay, now the question asks to solve for m, so we're not solving for y here. But remember, B and C share a common y because it's a flat line here. Alright, so that means to say the roots of this quadratic must be just 1. Right, so in other words, there must be 2 equal real roots, or we can just say that b squared minus 4ac, the discriminant is equals to 0. So that's the strategy. Alright, equals to 0. So b squared is negative 20 squared minus 4a and c. Right. This looks a little more complicated, but well, we can solve this. Not a problem. We can just solve this, and so this will be 400. This will be could multiply this out. This will be 100 minus 20m squared plus 100m minus 20m cubed equals to 0. Right, I think I've missed out the square here. Right, there's a square here. Now it makes a little more sense. There's a square here. This will be a square and this will be a 4. Alright, and I think 4 is common. We can just divide 4 away. So this will be 100 minus 100 plus, so that's 80m squared, so I can just minus 80m squared, and that's just plus 20m4. Alright, so the 100 can be cancelled out. So therefore we can simply see that we are left with 20m4 minus 80m squared equals to 0. And we can actually factorize this further. We can just take 20m squared out. So we will get m squared minus 4 equals to 0. Alright, from here you can see that m cannot be 0 because m's gradient. So therefore m is plus minus 2, or m squared minus 4 is 0, m is plus minus 2. Okay, so this makes a little more sense if you actually equate y into the quadratic and solve for y, because there's just one single root, alright, of y. Okay, and then following question B, find the coordinates of B and C. That's really easy. With m found, you can find the coordinates of B and C by substituting m into the equation here. Alright, or you can just substitute right into here. Okay, you can substitute right into this equation here. Alright, so if m is plus minus 2, so it doesn't really affect this equation because m's are all squared. So what I can do is I can just substitute in there. So if m is 2, 2 squared is 4. So 1 plus 4. Right, maybe I'll just draw an arrow here. I can just use that equation right there. Alright, so 2 squared is 4. 4 times 20 is 80. Plus 20. Okay, so 5 is common. I can divide 5 away. So 5y squared. So 5 is common. I can divide 5 away. I'll get 4y plus 4. This is a complete square. It has to be because that's just one y value. So therefore y is 2. Okay, with y as 2, alright, we can solve for the various x. So 2 equals to mx plus c. Alright, so therefore x is negative 4. Similarly, when you have 2 equals to minus 2x plus c, x is 4. Okay, so looking at the diagram, b has to be negative x, so therefore b is negative 4, 2, c is 4 and 2. Alright, so those are the answers. B and C. Alright, we are at the last question of this paper, last part of the last question. So find the angle BDC where D is on the x-axis, BDC. So let's look at the diagram. So we have B here, and we have C right there, and D. So maybe let me just recreate the graph, the diagram on the next side of the page. Alright, so the circle, alright, with D here, and let's just say B is right here and C is right here. Okay, so D, that's the angle BDC. Okay, with the y-axis right in the middle. Alright, similarly we have that's the reason why I think that's one of the reasons why the question given to you is in such an order where you're supposed to find B and C first. So C is 4, 2, B is negative 4, 2. And D we can find because the equation of the curve or the circle is given as this, 20. So for D, it's the positive side of x, so therefore y is 0. So x squared equals to 20, x is the positive root 20. That's D. Okay, so D is root 20, 0. Okay, so we have the points. We can use what we have done previously. We can use gradients to find out the angle. Alright, we need to find the angle BDC, the angle in between the lines BD and BC. So we can find the gradient of BD first and find the angle made with the horizontal. We can find the angle CD first, made with the horizontal, and then just take the difference as before, alright, in the earlier question. So first of all, we can find the gradient, which is MBD, alright, which is 2 minus 0 and minus 4 minus root 20. Okay, essentially that's the gradient. Well, we should expect a negative gradient because the line is sloping downwards from B to D. Okay, so if we were to inverse tangent of this angle, that will be the angle made from the horizontal to BD, because that's negative. So inverse tan of this, we get a obtuse angle. Alright, so what we can do is we can just try to inverse tan the angle. Inverse tan of this fraction to negative 4 minus root 20. So it gives a negative value, negative 13.28. So in other words, this part of the angle, alright, if you inverse tan of this negative value, alright, it gives about a negative 13.283 degree. So this refers to the angle here, alright, because if you take 180 minus the positive of this, you will get a obtuse angle on the other side. Alright, so you have to understand where does the negative come from. It's on this side. Alright, so we can do the same for CD. Alright, CD, so M of CD, the gradient of CD is y2 minus y1, x2 minus x1. So it's just 2 divided by 4 minus root 20. So again, we do the same. Inverse tangent of this expression, 4 minus root 20. Alright, it should be a negative value as well. So let's try that. So negative 76. So that's about negative 76.717 degree. So in other words, this part from the x-axis to C is negative 76.717. So therefore we can find the angle in between. We can just take the positive value. Alright, so angle BDC essentially is just 76.717 subtract 13.283. Okay, so that roughly gives you 63.4 degree. Alright, so that's the answer for question 11, part C. That's it for this paper. Thank you for tuning in.